For a speaker to make sound, it has to create positive air pressure. While the front is creating positive air pressure, the back is creating negative air pressure. If these two are able to interact, you'll get sound cancellation. So that's the main reason why when you test a speaker on a flat surface with no enclosure, you get no bass response. Enter the enclosure. So this type of enclosure is designed for two reasons. One is to separate the front and the back wave of that speaker so you reduce your cancellation, and also augment the resonant frequency of the speaker. What that means is, once you put the speaker inside of the enclosure, depending on the volume, it's going to change the bass response of that speaker. This particular speaker is made of MDF or medium density fiberboard, which is typically an acoustically inert media or material, and this one has a tune port inside of the enclosure. That tune port turns that inside air inside of the enclosure into like a secondary speaker, also called a Helmholtz enclosure, which basically uses the air trapped inside of this port tube as its own little air piston. So this one actually helps to augment the sound of the speaker that goes inside of here. These come in all shapes and sizes and have traditionally been made of MDF or some type of wood. So nowadays we're able to make enclosures out of 3D printed materials, and this one's made out of PLA. And what this allows us to do is make enclosures that are only limited by your imagination.